All right, so what kind of DE are we talking about when we're talking about phase portrait? Now, autonomous, every autonomous DE is also going to be what? Separable. Oh, exactly. It makes sense because it's only dependent on Y, so you can definitely get all your Y stuff together. Poor little X dude's going to be DX all by himself. So let me see, what if I do this here? What you got? Sure. Yeah, I like it. So then, of course, what's the first step of this? All right, so the question really is face portrait. We can certainly separate to solve it, but let's say the instructions are create a phase portrait. For blah.
We need to find a critical point.
Good. How do you find the critical points?
0.
Okay. Factor. So dy dx equals. How do you factor that bad boy? Let me see if you guys can handle this. This is something that normally I don't show my Math 110, but I think at this level you should be able to do this kind of thing. It's actually a method called the Texas slide. Believe it or not, it's not my name. You take for a second, you just, I don't know if you guys remember, you had to multiply these. It's called the AC method and all this crap. And for some reason, people, the X is magical and makes it easier for them. I personally don't know why that is true. It's the same exact work, but I'm like, whatever the hell makes it easier. But let me do this. That's not the same problem, but the answers to this will be related to the answers to this. So you slide that bad boy over. Now at the end, I'm going to have to slide factors of 4 back to the top. So that's just the sliding. So here, this is easy. What's this? Minus 8 plus 3. So I need a factor of 4 to slide back. Now sometimes you have to do both kind of things, but there's only a factor of 4 that can come out of here. Do you guys see how that's 3y and that's minus 8y? That's got to stay true. So if I slide a factor of 4 over, it'd be y minus 2, 4y plus 3. Now I still get minus 8 plus 3. I also get 4y squared minus 6. Beautiful. Have you guys ever seen that before? It's, once you're a little bit more comfortable with numbers, I think I should be able to say that about all of you in here. This method is preferred. It's just really nice. And it's just being able to play with numbers makes it pretty quick. Or you just do trial and error. That's also, the more you can play with numbers, the easier that is. So what are my critical points? Yeah, critical points. 2. 0? Yeah, negative 3/4. Right? So then you can start your phase portrait, right? The weird thing about the phase portrait is it's all vertical, which should make sense because it's all dependent on the y variable. So it's very similar to stuff you've done before with the whole sign diagram business. It's the same idea. It's just like this because now it's a y, not x. That seems to be, that's like a little technical detail, but some of you guys were doing this like this. No, it's got to be like this. And then I put on there negative 3/4 and 2. This, of course, is where it would be.
A chair or an asymptote.
Yeah, exactly. But even more, there's an asymptote for the in between these solutions here. But I want you to realize y equals 2 is the solution to this. Do you guys see that? If y is 2, this is 0, and what's dy dx? If y is 2, 0, the derivative constant is 0. So y equals 2 and y equals negative 3/4 are solutions to this DE. They are the particular, the singular solutions, right? So on this, I know that's true, but now I'm drawing an asymptote for these solutions, but I have to realize that's why for that one where I said y of 7 equals 2, what would the solution look like? Flat line. Because once y is 2, it's freaking always 2, right? Can't get off that line because this is where everything else wants to come to, right? Okay, go away. So now that I've got my critical points, how do you analyze these sections here? Well, if y is 18 billion, you get positive times positive, right? I like to go extreme. Or you can do 3 if you want. So it's positive. And everybody in here should understand the idea of multiplicity. Or even just on either side of the 0, these will change sign because they're both to a first power. If one of them was to an even power, it wouldn't change sign. So they change sign around their roots. So around 2 it should change, and around 3/4 it should change. I like it. Now this is the phase portrait. You don't even need the asymptotic, I like that. Asymptotic behavior to have a phase portrait. This is the phase portrait. The little drawings I do is extra. I'm not going to take off if you put them on there. I need to see this though. Cool. So what would you classify this as far as stability? Yeah, this is unstable, also known as a repeller. And this would be, yeah, this is stable, also known as a tractor. And the only other possibility would, of course, be if it was like this, maybe. That would be semi-stable. I like it. It's not an attractor or a repeller. It depends on which side you're on, to be honest. If you're repelled or attracted to it, go ahead. Is that cool? I mean, that's the heart, the basic idea behind any phase portrait creation is factor if you need to, critical points from the factors, put them down. It's just like a sign diagram turned this way. And instead of putting pluses minus, you put little arrows indicating is it increasing or decreasing. Cool. So what would it look like if there was a solution of y of -2 equals 1? Yeah, so which region am I in? 1, 2, or 3? 1, 2, or 3? I'm in 2. Why? Because these are what? This is the vertical axis, so this is the y-axis. Y is 1. This almost doesn't matter. You just have to make sure you go through the point -2, 1. So then you can kind of underneath this. Here's 2. Here's 1. Y of -2 is 1. And what would it look like in between? It's going to... Here's your -3/4. Yeah, it's gonna be decreasing, so it's got to go like this, right? So now you just make sure you go through that point, and then you got to approach that. Bang. Is that decent? Because you're going down the whole time, and this is asymptotic, so you pretty much have to look like that. Now, is this like the exact answer? No. Because where's the x-intercept? I don't freaking know, right? To do a little more detailed work to get that.
That's the solution curve for why, for that.
Yes, exactly. This is the, if you drew all the pictures, that's sort of like the general idea, but which answer is it depends on which region I'm kind of living in. It. That depends on what the initial condition is, what the initial value. And again, it should be easy. If you see y of who cares equal to 2 or -3/4, that's an easy one. It's going to be what? Flat. Beautiful. Because that's one of the two constant solutions to this. How are we feeling about that? Is that when you first talk about phase portraits, it feels so different. But then you start to see similarities between the idea of this and the ideas you've done before. It's really the same thing. Okay, I like it. Some of you guys look despondent. I'm sorry. Hopefully things will be better. All right, cool. I like that. That was a good suggestion on what to look at. One other little thing. when you do, if you had to look at the concavity, if you have to do d squared y dx squared, right, what would it be? It would be 8y minus 5 times dy dx, of course, because it's chain rule. So a lot of you guys forgot the chain rule piece for that concavity problem. I am taking derivative with respect to x. So all these y pieces, it would be dy dx to each one, but I just collected it outside. So actually, your critical points for your second derivative are going to be the same critical points as before, plus this new one. And if you think back to when you did concavity in 180, same kind of thing happened there. Very often, not always, but very often. Okay, I like it, maybe. Unless 180 was like 8 years ago, then you're like, I don't know. Okay, cool. So any more questions about face portrait ideas? Or, since we're on this topic, anything else about face portraits? You guys feeling all right? You guys doing okay? Are we in the 5th week now? I can't even keep track. I don't think in terms of weeks. There used to be a guy, he retired now. Every time I see him, he walked by, he's like, 12 more weeks, Jeff. He was my countdown guy, so. Me, I'm like, I have no idea what week we're in. But anyway, we're so far into the semester now. Hopefully, got the feel of this class a little bit. Yes?
On the bottom part, did you mean to draw an up and down arrow?
Oh, I'm sorry. Yeah, you shouldn't really put these arrows in. I was doing like a y-axis. Yeah. Those arrows get a little confusing. Thank you. All right. So nothing else about phase portraits. Okay, so what about anything else we talked about this semester? Have you guys had a chance to look at the practice test? I mean, more than just this. Oh, shit. Yes?
Can you do examples for Bernoulli's?
All right, Bernoulli's. So everybody got what they want here. What's the idea? What you should really do, I had a few people in my office earlier, what you should be able to say to yourself, especially for Bernoulli's and homogeneous or homogeneous, is what the purpose is for those substitutions. So what is Bernoulli's trying to do? Trying to take something and make it into what form? Ooh, I get some Bernoulli's is trying to make it linear. Because Bernoulli's is saying it's almost linear, except the stupid power on the y piece over there is too big. So it's almost there. So that's why they thought, well, maybe there's a way to make this work. Homogeneous does what? Tries to make it separable. I like it. So instead of just making one out of thin air, and who knows what's going to happen with it, let me take one out of this section. Here we go. Let's see. Let's try this one here. I like this one because you hopefully you start to realize that the thing about DE so far, and what's going to continue to be true for the most part, is I've got to know what form it needs to be in. I've got to be able to identify what I can use, and then I have to know what form to put it in to make it most useful. So what is wrong here, really? Why is this going to be Bernoulli's? Yeah, the y squared. Is that piece in the right place, and is something else correct? I mean, there's a little bit of cleanup I got to do, right?
Subtract the dy dt over to that.
Yeah, these have to switch, right? Because this should be the p of t in this case times y. I like it. So let's see if we can do that. T squared dy dt minus ty equals negative y squared. I like it. And then what do I do?
Divide by t squared.
Yeah, if I divide by t squared, I'll get dy dt minus y over t equals negative y squared over t squared. Now, there's a really nice way to do this, and I kind of laid it out for you when you were talking about the general idea of this. I can't remember exactly how I did it in the specific examples we were doing, but right now I can identify something key, something I definitely need to know, and what is that? What can I identify right now?
U.
Yeah,
For n.
n. What is n?
2.
2. So u is going to be y to the
Negative 1.
negative 1. Which means du dx, I'm sorry, du dt is going to be negative 1,
Y to
y to the negative 2,
dy dt.
dy dt. I love it. And why is that so beautiful? Because you got a dy dt term that needs to be replaced. You're really trying to replace all the y stuff with u stuff. That should feel remarkably familiar. So I do it basically exactly the same thing that somebody else did earlier in my office, and I did it last time, but I can't remember how big of a deal I made about it in the examples we did. Identify what n is, but then divide by this, the y squared. So you get y negative 2 dy dt minus, what would this be? 1 over ty equals negative 1 over t squared. And to be honest, if you're kind of thinking ahead, well, let's see if you guys get this. Now it's very easy to tell I'm on the right track. That's why I like to do this step. Why? How can I tell I'm on the right track? Because I want to put du dt in, and it's related to y to the negative 2 dy dt. The only thing is it should be negative. So all I got to do is just multiply both sides by a negative 1, and everything should match up beautifully. Let me just stop there for a minute. This is the way I personally would do this. I sometimes differ from the way the book does things. So you can do whichever way makes more sense. I think the book basically does it like this, not as in your face. So I would take negative 1 and multiply everything by negative 1. And now replace. This is going to be du dt. This is going to be
1 over t.
yeah, what's 1 over what? U. So it's going to be u over t equals 1 over t squared. Yeah, let me stop. How are we doing about this? I think I'll do this one and then I'll give you one to try. Yes?
How'd you get y to the negative 1 for you?
Oh, so I can identify, so once you get it into the form that's related to linear, right? Dy dt, function of ty equals what should be function of t, right? You can see the stupid power that's making it not that. Y squared, if only the y squared wasn't there. Okay, so n is 2, that power. So then, and now u is, what's the general idea? U is going to be y to the
1 minus n.
1 minus n.
Oh, okay.
I like it.
Couldn't you just multiply everything by u?
How do you mean? Do it again.
If you multiplied everything by u, you'd have a linear y. You'd have 1 over t, and you'd have negative, or you'd have y to the negative 1 times du.
But that doesn't really match up with, so if I divide it by y basically, right here you mean? So it seems like, I mean, this would become the term, if you divide it by y at the beginning, that could be a very easy trap to fall into. Because then suddenly that becomes right and that becomes right. Do you see what I mean by right? This term should be related to y, and this should be a function of t for it to be linear. But then you've got the stupid over y here, which is still keeping it from being linear. So I'm not going to ever shoot down an optimistic approach. But you try it and then you go, oh shit, that's why that doesn't work.
Because it's not linear.
Yeah, this term, if it would be over y, and that would be non-linear still. I like it. So there's no real way to escape Bernoulli's method if there's a need for it, right? Okay, I like it.
Would it be more work if you solve for y and then replace all the y's with u?
No, you could actually. You mean like before you do this derivative?
Yeah, because that's
Yeah.
usually what I do. I
Yeah.
solve for y and then I input the y's.
Yeah, so y equals -1, because then you see what dy dt exactly equals.
Yeah.
I like it. The reason I don't is if I do this, that's going to end up being this. But you can see how there's a whole other approach you could take. This is the point of, no, say this again. About 180 is the point where you got to go, well, they did this, but to me it makes more sense to do it this way. So you could change what you do here, which would change what you do here. But mathematically, it'd be the same stupid stuff, right? It'd be the same stuff. Okay, maybe, you guys. I mean, this is where, like I was talking to some other people, you've got to make math your own thing. You're going to go, all right, I can see what you're doing, but to me it makes more sense to turn this around. And then what would that mean I would do to the equation to make it match up, right? That's exactly what you need to be doing for yourself, right? So this is not me saying this is the way to do it. This is me saying this is the way I do it. You should be at the level where you can understand the math behind it and adjust it however you want to. If you don't want to adjust it at all, I understand. All right. Are we now linear in U?
Yes.
Yes. And what method do I use now? Yeah. So the integrating factor, how do I find that? Each of the integral, what's p? T, I love it. You start to realize if it was 2 over t, it would be t squared. If you do enough of these, you start to realize that's how that works. I like it. So if I multiply everything by t, and of course this is a step you can kind of skip really, but don't become a mu. So this side becomes, t times u. The integrating factor times the u in this case now equals 1 over t. Is that cool? Because this would be like d by dt. So I'm going to throw the dt over there. Is everybody with me? Integrating this side is easy. Tu, ln of t plus c. And u was 1 over y. I like it. T over y equals ln of t plus c. So then I can flip both sides and multiply by t. That's funky. I like that. And I know sometimes the hardest part is at the very end, you're like, what does he want me? How far do I need to? Oh shit. I want you to try, simplification somehow. You got to see if it's going to simplify. And you have to be able to tell if it's not going to really simplify. You have to be able to tell when you should try and when you shouldn't. You just have to. So, I mean, I'm not going to go crazy with taking the points off if you don't simplify it enough. You got it right, you just didn't simplify it enough. I might just put a little note or something. Unless it's like really bad, You should see something easy. All right.
So when in doubt, just solve for y if you can, or as much as possible.
Say again?
When in doubt, solve for y as much as
Well, in this case, solve for y because it's the
whichever one.
it's the dependent variable.
Yeah.
You won't always be able to, so but this one, if you stopped here, I go, well, no, come on. You got to go a little further. Okay, I like it. And I know you guys are like, what the hell's your definition of easy, Jeff? Oh well, I guess you'll find out. Is that cool? Let me give you guys one to try. Ooh, all right. That's encouraging. Let me hear me make that noise. Let's try this one. Hopefully you guys see how this isn't too far away. What are you? Really see the middle is supposed to be something related to y, right? Just to make sure everybody's on the right track. What do you do first here? Yeah, multiply the y in. And then what's got to be put over here? So you'll get dy dx equals xy4 minus y. So what's in the wrong place? The y. The y's in the wrong place, right? Because again, what's it supposed to be? It's supposed to be dy dx plus p of x y equals some function of x times y to the who knows, right? That's Bernoulli's. So you want to add the y over. Now that's in the right form. You can tell what n is. You can go forward now. So what it's all about. So if I were you, I might take some time just writing the form out several times so it just gets stuck in your head. Yeah.
So the x doesn't need to be on the other side?
No.
Okay.
Yeah. I mean, again, if you have this sheet, I didn't capture every little step down here because I really didn't want to necessarily, but the form you're looking for includes an f of x in front of y to the n. It's the f of x that's there normally for linear. It's just got that extra y to the n piece that we have to take care of with Bernoulli's. the step I just did is me making math my own, right? What's n? 4. So what's u going to be? Y to the negative 3, right? 1 minus n. And I mean, if you do that, you can very quickly see if you're on the right track, because you know that middle dude should be have the dependent variable itself, right? In this case, it's going to be u. And so if u is y negative 3, that's going to be a u right there. It's going to end up looking like it's linear. That's why I like that step, because it just makes sure that I'm on the right track. And then du dx is negative 4, yeah. dy dx. So what is it that I need to do up there to make it match? Multiply by negative 3, right? Cool. So negative 3, negative 3, negative 3. So now let's see. So I get that is du dx minus 3u equals negative 3x. That's always nice. And now now it's linear in u, so now I can attack it with integrating factor. I like it. What is my p of x? Negative 3. Oh, it's just a constant. So it'll be e to the negative 3x. I like it. What's going on, guys? Are you guys all right, or are you just waiting to see if I end up at the same place? Did everybody get e to the negative 3x there? Is that right? So then you multiply. Let's see if we just skip to it. If you multiply both sides by e to the negative 3x, this side becomes d.
E to negative 3x times
Yeah, u e to the negative 3x. So again, maybe this is not a good step to skip. So e negative 3x du dx minus 3u e to negative 3x. So this is when I did u, and this is when I did e negative 3x. So you can see that product rule happening. So that this step to this step makes complete sense. You could make it a shortcut and know it's always going to be u times your integrating factor, but it's nice to kind of see, oh, it's just freaking product rule. That's why it works that way. Now, and then what should if I write it like this, what should I put over there? Yeah, the dx, I can multiply it up over there, and now I can integrate both sides.
then that's just u e to the negative.
Yeah, exactly. So on this side, this is the beautiful thing about Bernoulli's and linear in general, you're going to just get that. That kicks ass. Integral d happy phase is happy phase, and integral d whatever is that thing. That's awesome. Equals, oh shit.
Product rule.
Integration.
Ah,
Integration by parts.
by parts is integration's answer to kind of like a product rule looking thing, right? Oh shit. So when you do this by parts, of course, what are you going to let u equal?
Negative 3.
Hell yeah, the part that wants to die, let it die, right? I don't want to die. Okay, no problem.
Negative
U is negative 3 dx. dv will be
e to the negative
e to negative 3x. dx. If we were really smart, we could have put that negative over there, but it doesn't matter really. v is going to equal
Negative 1 third.
u, negative 1/3. Right, that's the whole idea. That whole, like, by parts is where you really got to shift gears between things, you know what I mean? Because I can always hear, I can smell the smoke coming out of people's heads when they're like differentiating on one side, they got to integrate on the other side. You always get the differential here. Oh shit! So you got to shift gears between the two. So how's this work? It's going to be
X to the negative 3x minus.
so integral u dv equals uv.
Minus the integral of VD.
Exactly. So then you get uv, which is negative 3x negative. So the negative 3, negative 1/3 kill each other. So you just get x e to the negative 3x. Yeah, minus the integral of v. du. Oh, there's a negative 3. All right, let me just put a negative 3 there. We'll clean it up here in a second. So this is my v du. U e negative 3x equals x e negative 3x minus the integral of e negative 3x, which is,
1/3.
yeah. U was, oh yeah, y to the negative 3. Say again?
Your VDU? Because you're,
Yeah, these went away.
oh,
It became a -1, and then I integrated, I picked up another negative 1/3. Yeah, you gotta trust me on this part.
I got you.
Again, I mean, you can always show yourself more than I show on the board. But please, dear God, I'm human. I will make mistakes, so feel free to point out if you think I have made a mistake. I'm not so arrogant as to be like, well, screw that. So you get y to the negative 4. Notice how you can multiply by e to the 3x. So you get x plus 1/3 plus c e to the 3x. This is funky. I like this one. How are we doing? Is that? You guys are looking
What is it?
concerned.
Negative 4. Should it be negative 3?
Negative 3, yeah, thank you. See, there you go. And then you just have to, really, you only just have to flip both sides, to be honest. Don't worry about taking a big-ass cube root. All right, you guys, so you can make it y cubed equals 1 over all that stuff. And that's fine to stop there. You can make it a cube root, it's not going to be wrong. Especially if you got to take a square root, don't take a square root. You know, plus or minus, don't do that. You can have an implicit answer. That's funky dumb. Now, of course, if you have time, you can check to see if this works. I don't think I would. It looks like something where the derivative is going to take a while, so don't waste time doing that. But I mean, more important than any specific little something in this is just the overall idea of what to do. So yeah, you do have to remember by parts. You do have to know how to do by parts. But at this point, that should be semi-ingrained in your soul, almost like U sub, right? This should be there for you. Trig sub, I understand, might not be exactly there for you because you don't get to use it that much besides in 280, really, unless you have a teacher that makes it show up sometimes. All right, is that decent? I mean, you guys talk about not being able to read. Yes?
Are you going to throw trig substitution in?
If I was just thinking, if I did, I might have a little hint or something.
Hint now or?
Huh? No, like hint on that thing. It might say on the top. You might need trig sub somewhere.
Oh, okay.
Boy, that's a helpful one. All that does is gonna make you sweat a little more. What, really? Shit? Where is it? This one? Is this? No. Maybe I won't do that. Maybe I'll do something a little bit nicer. We'll see.
It's a good question.
So it might be a good thing to review trig sub. Okay. So let's see, we did an example. I had you guys do one semi on your own there. The important thing is to realize what is it that tells us what to do, and do you know how to do it? There's two separate things. That's why I love it when they separate the sections like this. Do you understand the process, and then you have to be able to step back and go, do you know when to do that process? I mean, that's a lot of math is, the hardest part of math is when to do something, when to do what. You guys had a chance to try out that practice test at all? Somewhat, a little bit. Some of you guys like, mm-mm. You don't have to look at it at all if you don't want to. To be honest, it's just extra practice. All right, you like the homework's plenty, okay? Let me give you the answer key for that. I had to put 4D on the back, the rest of it. There's one for her in there. So I feel like I shouldn't necessarily have to say this, but I'm not sure how familiar you are with practice tests. But my practice test is about the concepts. So there will be the same concepts on the actual test. I'm not just going to take number 1 and change the cosine 2x to cosine 3x like some of my colleagues actually do. Hopefully you guys see, on number 1, if you tried it, that was a misprint, that y. It should have just been a single y. Right? Otherwise I just would have made it y squared. So hopefully you didn't go insane trying to. If you did, you're doing a really good job of keeping it tampered down right now. Let me see, anything else on here? Freaky. 4, I started telling you what it was: separable, linear, exact, and then I was like, screw it. Part D is obviously Bernoulli's. So that's what I finished up on the back. I think it was Bernoulli's. Let me see. Yeah. Oh, I forgot to do number 6. We could do that one. Let's see. Oh, well, I mean, you know, creating a direction field by hand would be disgusting. All right. If I give you a direction field and like a point in that direction field, you should be able to just follow the arrows. I mean, that's really all that number 17, that number 6 on the practice test. And this answer should be in the back. It's their chapter 2 review. So you can just take a look at that. But it's got 2 little initial points that they want you to draw a solution curve through. Okay. I just realized I didn't really put a homogeneous one down there. Did I? Nope. So we could do a homogeneous one if you want to, or yeah, okay. Let's see. Let's just go back here.
So the only graphing on the test would just be the phase portrait, right?
Yeah, phase portrait. The graph is not going to be perfect, but it has to go through. If I give you initial condition, initial value, I might do just like number 17. Give you a direction field and ask you to sketch solution curve given a point on the curve. But beyond that, there's not going to be any more graphing than that. Let's do a homogeneous one since I didn't have one on there. Let's see, blah, blah, blah.
Is the test going to be similar to this length practice test? It's going to be like 2 pages?
Oh, the test will probably, it'll be at least this long. I might have a couple of quick conceptual questions that you either know or don't. So those will be quick, one way or the other. They'll be quick. I know I can't make it much longer than this because some of these obviously took a little bit of time to get through. So I'm not going to like load you down. I want to give you a little bit of time to be able to kind of roughly check your work, right? So I'm not going to. So if it's a little longer than this, it's going to be some conceptual questions that are like quick answers, you know it or you don't. kind of situation. Let me see. Let's do. Where's a good one? There we go. This one's interesting. Let's see. Okay. All right, let's do this one together a little bit. What's a good first step for this one here?
Multiply everything, whatever, it's cube.
Yeah, maybe. Yeah, general good first step, if you can't quite identify it, is to clear the shit in front of this, right? Because most forms involve nothing in front of this. You with me? So I understand what you're trying to do there, Joseph, but it actually will work out nice if I just divide each thing by this. So I end up with dy dx equals y over x minus square root of y squared. Like some of you guys are like, why?
Then you just make u y over. Right?
Yeah, okay, so if you let, say y equal ux, so u is y over x. So the dy will be
Yeah.
u dx, so x du. Now, some of you guys might be concerned about this here. Well, let's just see what happens. Because we cleared the dy dx coefficient. We saw that there are ratios of y's to x's. So then we thought, okay, let's try homogeneous. So let's see what we get. We get, let me rewrite this a bit. So dy equals y over x minus x squared over y squared dx. So now I've got dy, u dx, plus x du, equals u minus u to the negative 2 dx. Now see, the nice thing then now, the reason you shouldn't be too concerned about this is because the homogeneous substitution is aiming to make this become what? Separable. So notice something very quickly. I mean, this is u dx minus u negative 2 dx. What's really nice? Is anything really nice? Yeah, the u dx is canceled. You always look for that because it doesn't always happen, but very often it will. Something will cancel. And now this is beautifully separable. Right, I get u squared du equals negative, bless you, dx over x. Multiply by u squared, divide by x. See, now that's why if homogeneous is one of the types it's in, I'm going to be drawn to do that. Because it makes it separable, which is arguably the easiest type. Is everybody cool with the steps so far? Yes?
Is there a reason you left the negative with the dx?
Not really. How do you like that? I mean, I could have put it over here, but there's no real reason either way. Yeah. One little tiny thing, though. Let's see. If I had like negative y equals x squared plus c, and your next step was this, I really want you to start to understand why that's wrong. And on this level right here, it's like, what's the big deal? But pretty soon we're going to have C1 and C2 and C3, and they're going to be doing things. I mean, so I got to keep track of what each one really is. And I might have systems of differential equations. Oh, shit, Jeff. And then if C1 gets the wrong sign, it's going to mess up between the two. Oh, shit. You got to keep better track of your constants now. I do have a few people that are like, if it's like this, the next step is this. What's wrong with that? Yeah, exactly. It should be this, right? You can't just put the plus C at the end like you could back in 180. Now your C could end up anywhere. It could be a coefficient of something, it could be on the bottom, it could be inside